All right, everybody got your things on mute? All right, good. Welcome back to the Tutor Learning Center. This is JD Tutor, and I'm here to teach you more about getting ready. We got cut off when we tried to do number 10. So let's do number 10, and then we'll keep going on into the lessons. So number 10, the Venn diagram below provides a visual representation of the students in Mr. Griffin's class who participate in music programs after school. What does the diagram tell you about the musical involvement of student B and student G? Explain how you reached your conclusion. All right, so here we have students who play the piano. Let me get my pencil out. Students who play the piano and students who are in the band. And let's see, we're looking at B and G. B is in the overlap. So this student plays the piano and is in the band. All right, does everybody see that? Plays the piano and in the band. Okay. Actually, that's only B. Right. And G is only in the band circle. Okay. So student B participates in both piano and the band. Okay. And that's student B, and student G participates only in the band. Does that make sense? And that's pretty simple, right? Does everybody understand that, the Venn diagram? How the middle, basically, they're telling you how the middle is overlapping, right, between two things, right? Okay, that was number 10. Let's go to lesson 1-1. Okay, identify patterns in the data. Use tables, graphs, and expressions to model situations, and use expressions to make predictions. Mising spent his summer vacation traveling cross country with his family. Their first stop was Yellowstone National Park in Wyoming and Montana. Yellowstone is famous for its geysers, especially one commonly referred to as Old Faithful. A geyser is a spring that erupts intermittently, forcing a fountain of water and steam from a hole in the ground. Old Faithful can have particularly long and fairly predictable eruptions. As a matter of fact, park rangers have observed the geyser over many years and have developed patterns they use to predict the timing of the next eruption. Park rangers have recorded the information in the table below. All right, well, we have length of time of eruption in minutes and approximate time until the next eruption in minutes. All right, so let's look at this. One, in length, it goes 1, 2, 3, 4, and then it also goes up in minutes. So 1 to 46, 2 to 58, 3 to 70, and 4 to 82. Describe any patterns you see in the table. Well, if you're going from 46 to 48, so 46 to 48, it's going to be 12 minutes. If you're going from 58 to 70, it's going to be another 12 minutes. So these are going up by 12 minutes apiece, aren't they? Yeah. Okay, so the length increases by 1 minute in each time. And the wait time increases by 12 minutes in each time. So here's our wait time. 12 minutes each. Okay, so this is a linear pattern. For every 1 minute increase in eruption length, the wait time increases by 12 minutes. Does that make sense? So if you had something like this, which you will eventually, you've probably already seen, okay, y-axis, x-axis. So you're going to have your length of eruption, right? And your next eruption, right? Something like this, right? And it's going to go upward in a linear line, right? Does that make sense? Okay. Okay, number 2. Why is this important for park rangers? All right. So why would it be important for park rangers to be able to predict the timing of Old Faithful's eruption? Well, they can use the pattern to predict when the next eruption will occur. This will help them inform visitors, manage crowds, and ensure safety. We don't want to be out there. First off, you don't want to be out there when the geysers are going to be uh, with geysers that are going to be blowing up out of a hole, don't you? You don't want to be out there, do you? Okay. Well, it also ensures safety, right? Manage crowds and inform the visitors when the next eruption will occur, right? Mhm. All right, number three. Um, if an eruption lasts 8 minutes, how long must park visitors wait to see the next eruption? Explain your reasoning using the patterns you identified in the table. All right. Well, each step adds 12 minutes. So we continue the pattern, 12 minutes each step. From 4 minutes, which is 82 minutes. So let's look over here. 4 minutes and 82 minutes. Okay. Go to 8 minutes. Well, what happens when we go to 8 minutes? 5, 6, 7, 8 minutes. Okay. So we have 4 steps that we've got going on here. We can say 8 minus the 4 will gives us 4 steps. Okay, so we can take the 82. Is everybody watching? Okay, so we're taking the 82 from the 4 steps. Okay, and we're going to plus it with the times 4 times the 12 steps. So 4 steps times the 12. That's the wait time. Okay, so we have parentheses first, so 82 plus 48, and then we're going to have equals 130. So we have 130 minutes for the next eruption. Does that make sense? Okay. If it doesn't, let me know. Okay. Number 4. Okay. Graph the data on the grid below. All right. Plot these points on the grid. So what we're plotting is 1 and 46, 2 and 58. We're making ordered pairs. Remember the ordered pairs from the videos we were watching? We're making ordered pairs to get these up here. Okay, so just plot those on the graph. And remember what I was telling you about it makes a linear line going up on your X and Y axis. Well, here we are. Let's see if I can get this a little bigger, guys. All right, so we're going to plot 1 and 46. So we're doing our X axis and our Y axis. X, Y, X, Y, X axis, Y axis. So 1. So we go across the X axis first to 1 and to 46. Looks like what? It's around about there to 46, just below the 50 mark. 2 and 58. All right, I need everybody's attention. Okay, 2 and 58, right above here. 3 and 70, right here. And 4 and 82, right about here. Okay, do you see where it forms a straight line? Okay, it forms a linear line. So they all increase by 12 each time. So they form a straight line, which is linear. It's a linear relationship. Number 5. Meising and his family arrive at Old Faithful to find a sign indicating that they had just missed an eruption, that it would be approximately 2 hours before the next one. How long was the eruption they missed? Explain how you determine your answer. Well, you have 12 minutes each time. So 12 minutes. Let's see, 2 hours until the next one. So let's see. Um, how long is 2 hours? Right. So 2 hours equals 120 minutes. Your wait time is 12 minutes. 12-minute wait time. Okay. All right, good. So let's see. Let me see if I can get back up here. Let's see, let's see, let's see. All right, so let's see where they got that 34 from. So in problem 5, where did you get the positive 34 from? Oh, nope. Problem 5 with the geyser. Well, okay. So it's a step that they left out. All right. So does everybody remember y equals mx plus b? Everybody? Okay. So y equals mx plus b. Does this problem mirror our y equals mx plus b? Let's put our 12-minute wait right there for the slope. Okay. So remember m was the slope. B was the y-intercept. Okay. All right. So let's see. So we'll use the first point for the geyser. So we're going to insert 1. Remember 1 and 46? All right, on your chart up above. Right. So we're going to replace the x with 1 and replace the y with 46. Okay. And that's how we got our 34. Okay. So B. It was 34. That's how we got that. Does that make sense? All right. So we did minus and minus 12, right? Cancel, cancel. So B equals 34, right? Okay. So that's how we got our 34. Let's go back up, 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 up. All right. So now does everybody understand that was our 12-minute wait? This was our 34 that we got from our y equals mx plus b, right? This was our minutes that we converted 2 hours into 120, right? And so now we just take and minus 34, minus 34. We're working to get x by itself. Okay. And so here we are with 12x and 86 equals 86. And divide by 12. What you do to one side, what you do to one side, do to the other. Right, cancel, cancel. And so it's going to be x equals 86 over 12, which is 17, I'm sorry, 717. All right. Did everybody understand that? Okay. All right. You guys should have already had these videos. All right, number 6. So, it says on number 5, the eruption they missed was about 7 minutes long. Another thing you might find on your ACT would be patterns and sequences. Okay, so using the table or graph above, write the approximate times until the next Old Faithful eruption as a sequence. All right, so from the table above, you're going to write 46, 58, 70, 72, and they're all going to be 12 each. The wait time is 12 each. Does that make sense? Okay. Number 7. How would you describe the sequence of numbers? Well, it'd be 48 minus, 58 minus 46 is 12. 70 minus 58 is 12. And 82 minus 70 is 12. Right. The answer is arithmetic sequence with a common difference of 12. Does that make sense? Okay. Next one. All right, number 8. We're on lesson 1-1, guys. Still on lesson 1-1. Number 8. In the table below, 5 and 8 are consecutive terms. Some sequences have a common difference between consecutive terms. The common difference between the terms in the table below is 3. All right, so identify 2 consecutive terms in the sequence of the next eruption times that you created from item 6. Well, let's look at item 6. We said we had 46, 58, 70, 82, and so forth, didn't we? Okay, consecutive terms are any terms next to each other. That's what consecutive terms are. So consecutive terms are any terms next to each other. All right, so let's look at our examples. We have 46 and 58, 58 and 70, and 70 and 82. Those are our consecutive terms. We actually identified 3 instead of 2. Okay. The next sequence of eruption times has a common difference. Identify the common difference. Okay. Number 9. All right. Well, the common difference, as we have said before, is 12. 12 in each, right, Braden? Okay. Right, Rain? Right, Kylie? Okay. So the common difference is 12 in each one. Is 12. Making sure y'all are still awake over there. All right, number 10, 10A. Oh, there's a B, C, and D. Okay. Each term in the sequence above can be written using the first term and repeated addition of the common difference. For example, the first term is 5. Okay, the second term is 5 plus 3. And the third term can be expressed as 5 plus 3 or 5 plus 2 times 3. Similarly, the terms in the sequence of the next eruption times can also be written repeated addition. Hold on, guys. Sorry about that. Similarly, the terms in the sequence of the next eruption times can also be written using repeated addition of the common difference. All right, write the approximate waiting time for the next eruption after eruptions lasting 4 and 5 minutes using repeated addition of the common difference. Okay, so for 4 minutes, we said, let's see. All right, so for 4 minutes, we have 46, and our wait time was 12. So we're timesing it times 3. Okay, to get 46 plus 36 equals 82. For 5 minutes, we're going to go up 1 because these are our minutes, right? So 5 minutes, we're going to have 46 plus 4 times 12 equals 46 plus 48 equals 94. Does everybody understand? Okay, good. So the first one was 82 minutes for 4 minutes, and 5 minutes was 94 minutes. Okay. So 82 minutes for 4 minutes was 82. For 5 minutes was 94. Is that what you guys have in your notebooks? Okay. Let's look at B. Let N model with mathematics. Let N represent the number of minutes an eruption lasts. Write an expression using the variable N that could be used to determine the waiting time and the next eruption. All right, so, well, we can say y equals mx plus b. Does that mirror y equals mx plus b? Yes. All right, and we can say this was our minutes, right? And this is what we had when we substituted, remember, to get our 34. Y equals 12n plus 34. Okay, so we're just taking in A, B, and C what we've learned, and we're just putting them in here. Does that make sense? Okay. All right, check the accuracy of your expression by evaluating it when it was n equals 2. Well, remember, we're going to do y equals 12n plus 34, and we're going to insert our 2 in, right? N equals 2. Oops, not n. 2 plus 34, okay, which gives us 24 plus 34, and y equals 58. So y equals 58, and that's for C. Does that make sense? Okay. And D. All right, use your expression to determine the number of minutes a visitor to the park must wait to see another eruption of Old Faithful after a 12-minute eruption. All right, so we had a 12-minute eruption. So use your expression to determine the number of minutes a visitor to the park must wait to see another eruption. All right, well, let's give an example. If you have an eruption that is 6 minutes, right here, we're going to say y equals our 12n plus 34. Y equals 12, and we're going to say 6 minutes. Right? And then y equals 72 plus 34. So y equals 106 minutes. So 106 minutes. So use your expression to determine the number of minutes a visitor to the park must wait to see another eruption of Old Faithful after a 12-minute eruption. So it's 106 minutes. All right, guys, so we're going to stop right there. It's about lunchtime, so we're going to stop there and continue with the rest of it after lunch.